We were really interested, or we have been really interested for the past couple of years, of trying to understand how robots and humans can work together. And that doesn't mean robots working side by side with humans necessarily. It's really how can you use humans and robots overall to improve the way that we do exploration. And in particular, how can we use robots in advance of humans for lunar exploration. Here at the Lunar Science Institute, we have a ground control team that's remotely operating our K-10 robots out at Black Point, lava flow in Arizona. And we have two teams. We have a science team, which is really worried about strategic planning. They're trying to figure out where to send the robot, at different locations, what should the robot do. And within that team, we have a number of different people doing different things. We have an overall robot investigator. He's the robot scientist. He's really worried about trying to use the robot to get certain types of science data. He's the person really responsible for the overall way the robot works. Supporting him, we have a number of other scientists. Here for this test, we have planetary scientists and field geologists. They're trying to make sense of the data. They're trying to figure out what is the robot seeing and how does this relate to the overall site. Supporting those people, we have people managing what we call our ground data system. That is the software system that manages all the data gathered by the robot. And they're responsible for making sure that the data is available to the scientists as they're trying to analyze and review and visualize what the robot is seeing. So that's one room, the science team. They're really doing strategic planning. Down the hall we have the flight control team. And that team is really responsible for taking the plans developed by the science team and turning those into action. So making the robot actually go to the places the science team would like the robot to go, making sure that every place where the science team says take a reading at the location 1 or 2 or 3, that the robot actually does that. And the flight control team is very tactical in nature. So they're organized in a way that's inspired by mission control at NASA Johnson. So there's a flight director. He's in charge of the overall team. His job is to make sure that everybody is coordinated and is working together. So he talks to his individual controllers, and these are people that have different responsibilities. There's a science officer. That person is really the link between the flight control team and the science team. Really trying to understand how the plan relates to the overall operation, the overall mission that we're doing. In addition to the science officer, there is a robot driver, and that person actually probably has the most fun job of all. He's the person who gets to drive the robot. And we operate our robot in a couple of different modes. It can operate basically by itself, autonomously. The robot's smart enough to know how to get from location A to B without running into things. But sometimes when the terrain is too difficult, sometimes when the robot's not capable of making the right decision because there's something unexpected, the robot driver will take over and joystick the robot. Another person in flight control is the robot system monitor, and he gets the fun job of really looking at every little bit of information coming from the robot, understanding how different systems and subsystems work. He's looking at power and thermal and computer load, the data bandwidth, how much data is being transferred to and from the robot. He's really trying to make sure that all the systems on the robot are working well. Another person in flight control is the data manager, our data downlink person. And his job is to make sure that the data, so the images and the laser scans taken by the robot, are transferred from the robot back here to NASA Ames. He wants to make sure that the data that the scientists want actually get taken off the robot and brought back home. And then there's one final person in the overall flight control team, and that is the robot performance monitor. We've been very fortunate to have an SBIR project developing systems to really understand how well is the robot doing versus expectations. So this person has developed and is using a software system that allows us to, in real time, look at the telemetry, the data stream coming from the robot, comparing how well the robot's doing, for example, driving from location A to B versus what we thought it was going to do. And this is really useful for giving overall awareness to the various other people on the team of, well, is the robot doing well? Are there things we need to do better? Is there potentially a problem to take a look at?